everyone, I am Hemant Sathwara, and today in this lecture we are going to discuss about depletion MOSFET. So as we discussed in our first lecture that transistor is divided into two parts, one is BJT, another one is UJT. So in BJT we have discussed PNP NPN transistor, whereas in FET or we can say in UJT we are going to discuss about JFET and MOSFET. So in this topic we are going to discuss about MOSFET. So MOSFETs are divided into two parts. First one is depletion MOSFET and second one is E-MOSFET or enhancement MOSFET. So in today we are going to discuss about D-MOSFET, that means depletion MOSFET. So let us start with basic about D-MOSFET or MOSFET. MOSFET, that means metal oxide semiconductor field effect transistor. It is the another type of FET. Metal represents metallic contacts which are gate, source and drain connected at few points. Oxide represent SiO2 layer, which means silicon dioxide layer. D-MOSFET, that means depletion MOSFET, the transistor requires gate to source voltage to switch the device off. The depletion mode MOSFET is equivalent to closed switch. That means it is also known as normally closed switch. With increase in negative gate voltage, drain current will reduce. So that means depletion is penetrated into the channel, and due to this depletion region it is known as depletion MOSFET, or we can say D-MOSFET. So depletion MOSFET, D-MOSFET is divided into two parts. Number one, N-channel D-MOSFET and number two, P-channel D-MOSFET. So in today's lecture we are going to discuss about only N-channel D-MOSFET. So let us start with its symbol and its construction. So here we can see these are the symbols of D-MOSFET. Here this is the P-MOSFET symbol, and there we can see this is the N-channel D-MOSFET symbol. So there is a small difference between N-channel and P-channel. If arrows goes inside, that means it is known as N-channel D-MOSFET, and arrow comes outside, that represent P-channel D-MOSFET. So there are similar three terminals: drain, gate and source terminals. So MOSFET body is usually connected to the source terminal. So substrate and source is shown connected together in the symbol. Here we can see the arrow line and source line is connected at one point. So that's why, because it is connected substrate to source. Now here we can see the symbol of N-channel and P-channel. So these are the about symbol of N-channel D-MOSFET and P-channel D-MOSFET. Now let us discuss about its construction. So here we can see this is the N-channel D-MOSFET construction. So it is totally different compared to the JFET. So here we can see there are three different types of terminals. First one is drain, then next one is gate, and below we can see source, and here we can see substrate terminal. So it is known as MOSFET. So why it is called as MOSFET? So M for metal. So here we can see dark line. Here one dark, and there three different dark portion is metallic contacts which are connected to the different terminals: drain, gate and source. So in metallic contacts we can see here gate only terminal which is not directly contacted with the region, whereas drain and source terminals are contacted, or we can say connected to the N region. Now this is N channel D MOSFET. That's why here we can see this is the source and drain which are connected to the N type region, and between this N type drain and source there is a channel which is N channel with connected to the drain and source. Here you can see in this area, this is the P region. Okay, so number of holes, majority carrier charges are here, and here in N type region there are majority carrier charges are electrons. Now these are the construction. So metal, clear. After this O, that means oxide, because here we can see here this line represents silicon dioxide. So silicon dioxide is an obstacle, or we can say it is the layer which differ or which divide gate terminal and N-type region. Here we can see this side, it is not connected directly with the N-type region. So this layer is silicon dioxide, that's why oxide. Metal oxide semiconductor. So this material is built from the semiconductor material, that's why it is known as metal oxide semiconductor, and it is the type of FET, that's why field effect transistor. Due to field is created due to this VGS, number of electrons flow downward to upward direction. That's why it is known as field effect transistor. So now we are going to discuss about this theory into different cases. Now case number 1, N channel D MOSFET construction. Here we can see this is the biasing of N channel D MOSFET. Here we can see in case number 1, VGS is shorted. Here we can see VGS is shorted, that means VGS is equal to 0 volt. So let us first explain different cases. Now we are going to conclude cases wise, and we plot a graph of characteristics of D MOSFET. So in case number 1, we will discuss about VGS is equal to 0. Then we verify what happens if we apply VGS is equal to 0. Case number 2, if we apply more and more negative voltage, then what happens in this construction? And finally, case number 3, if VGS is positive, then what happens? We will verify according to these 3 cases. So here first we are taking case number 1, VGS is equal to 0. That means here gate and source terminal are shorted. Simple. So if we shorted these 2 terminals, that means VGS is equal to 0. No voltage will apply at this terminal. So if there is no voltage, that means no field generated at this gate terminal. So there is no obstacle for the flow of electron. Now here we can see VDD. VDD, that means it is drain supply, drain voltage. If we increase this voltage, that means the flow of electron, here majority carrier charges are electron, and this electron always attracted towards the positive terminal. So it flows from source to drain. That's why here we can see ID, that means drain current, is equal to IS. IS, that means source current, and is equal to, here we can see IDSS, that means it is the drain to source saturation current, because if VGS is equal to 0, at this time your drain current flow is maximum. So remember this case, we are gonna apply it in characteristics. So this is the case number 1. Now let us discuss about case number 2. N-channel D Mosfet, if we provide more and more negative voltage. Now here we can see this is the construction of channel. Here we can see this is the channel construction, and only gate terminal is available in this figure. So if we apply negative terminal, here you can see it is indicated as minus, that means we provide here negative supply. So first polarity should be minus. If we apply negative voltage, that means here in this channel there are number of electrons, majority carrier charges are. So it always repel, because here polarity is also negative. So same polarity, due to same polarity here electrons are repelled. So here in this material, we can see in this material there are majority carrier charges are holes, and it attracts towards this negative polarity. Due to this process, electron and hole make a pair. So if we increase negative voltage, that means if we increase negative VGS, so more and more electron hole pairs are generated. That means electrons are busy with these holes and make electron hole pair. So that's why there is a reduction in number of electrons, and due to this the flow of drain current becomes reduced. So for example, if in first case there are number of electrons are 100, if it make a pair with holes, that becomes 50. So due to this 50 electron, the flow of current is comparatively low. So this is the case number 2. If we increase negative voltage, due to this negative voltage, electron hole pairs are generated and reduction in number of electrons, and that's why the flow of drain current becomes reduced. Now let us discuss about case number 3. So if we apply VGS in positive side, then what happens? So we should connect first polarity positive at the gate terminal. So if we apply positive terminal and we increase gradually, so in N channel there are number of majority carriers are attracted towards the positive terminal, and also in P channel there are majority carrier charges are holes and minority carrier charges are electrons. So that minority carrier charges also attracted towards the positive polarity. So first, for example, if there are 50 electrons in N channel and 50 more electrons available in P-type region, so that P-type region electrons join this electron due to more and more positive voltage. That's why the number of electrons are going to be increased, and due to this number of electrons are increased, the flow of current also increased. That's why it is known as enhancement, because here the flow of electrons towards drain is increased. So this region is known as enhancement region. So let us discuss about this 3 different types of cases in characteristics. Here we can see this is the characteristics. This characteristics is known as drain characteristics, or we can say output characteristics, and from this drain characteristics we can plot transfer characteristics, which is represented here. So first, case number 1, we apply VGS is equal to 0. At this stage, VGS is equal to 0. At this time, your drain current is maximum, which is known as IDSS, drain to source saturation current. So due to VGS is equal to 0, you can plot drain current in the transfer characteristics. Now, case number 2. If we applied more and more negative voltage at VGS, that means VGS is equal to -1, -2, -3, -4 and -5. That means there is a generation of electron hole pair. Due to this generation, the number of electrons becomes reduced, and that's why your ID, your flow of ID becomes reduced. So here we can see whenever we increase VGS value in negative side, VGS -1, -2, -3 and -4, your drain current, which is plotted in transfer characteristics, is become reduced. So this is the case number 2. Now let us discuss about extra case number 3. If we gonna increase in positive side, then what happens? If we increase VGS in positive manner, that means number of electrons are increased. That means the flow of current is increased. Here we can see if your VGS is equal to +1 volt, at this time your current is maximum. It is maximum than the ideal message. So that's why it is known as enhancement Mosfet. So we are gonna discuss about in E-Mosfet. So these are the conclusion of 3 different cases. So this is the N-channel D-Mosfet. So that's all for today's lecture. If you have any query related to this topic, you can mail me on this email address. Till then, keep learning, keep reading. See you soon in next coming lecture. Thank you.